Welcome to our YouTube channel named as Cat2. I am by Manoj Mahajan. Don't forget to subscribe to the channel if you have not done yet, as we are coming up with Quantitative Aptitude full course relevant for CAT, ZAT, NMAT, SNAP, and OMETS. So we are starting with a very important module, Arithmetic. The agenda for today is percentage topic. I'm going to cover up basics of percentage, reciprocals, triplets, wonderful method to solve questions with ease, change of base. So do check out the video till the end. So let's first start with basics of percentage. So percent word I'm dividing as per cent. So this cent is 100. So if you want to convert a number into percentage, we actually look forward to multiply with 100. So let's say if I give you one example, the maximum marks in the exam is 500. Marks obtained is 400. So we're going to use the unitary method. So out of 500, you got 400. Out of 1, 400 by 500, which we can simplify to 4 by 5. Out of 100, if I look over here, 4 by 5 into 100. So we actually converted the number 4 by 5 into percentage by multiplying with 100. So we got 80%. So just remember the first thing out here, any number, if you want to convert into percentage, multiply with 100. And the percentage figure, if you want to convert back to number like 80%, so what we do is we divide by 100 by removing the percentage sign. So we get as 4 upon 5. So these are the two basics you should remember. Let's move to the other basics of the percentage. So to understand the other basics of the percentage, let's first understand the change. So how do you get the changes? Final minus initial. And how you get the percentage change, that is very important because in most of the questions they ask you this. So that is final minus initial upon initial into 100. So if you look over here, this can be written as final upon initial ratio also minus 1 into 100. So remember one thing, if I want to figure out the change value in a problem, so I need to know the values of final and initial. But if I want to figure out percentage change, even if I know the ratio of final and initial, I can actually get the value. So let me tell you with one example what I mean over here. So let's say you have initial value I and there is an increase of 20% on it. So my final value I can calculate as I plus 20% of I. So removing the percentage sign, can I write over here 20 upon 100 I? If I take I common and if I simplify 20 by 100, I do get 1 by 5. Ultimately, I can write as 6 by 5 I. Also, this can be written as 1.2 I. So this 1.2 I, or if I look 6 upon 5 I, that would actually mean the same. So this number 6 by 5 or 1.2, I am terming as multiplying factor. So in a lot of questions, we're going to use the concept of multiplying factor to make things easy for us. So if we know the multiplying factor, we can actually look forward to get the percentage change. So let's see out here, percentage change, if I look over here, what is my final value? That is nothing but 6 upon 5 I upon I if I do. So I would cancel out. So I just need the multiplying factor. So 6 upon 5 minus 1 would give me 1 upon 5 into 100 if I do it. I do get what? 20%. That was the change also what we did over here in the problem. Now, if you want to figure out the change, I can just write in terms of I. I won't be able to get the exact value. So 1.2 I have the final minus I. So this becomes 0.2 I you can write or maybe I upon 5. So that would mean the same thing. So it would actually depend on the initial value if I want to get the value of change. But percentage change you can calculate as the multiplying factor you were aware of, that is 6 upon 5. So we are going to look at some percentage figures also in a while, so that these fractions are damn important for you. And further, we are going to look the multiplying factor concept also, so that we can make things easy for us. So if you look over here, the concept of reciprocals. So what we are up to over here is we would be having numbers in terms of fractions, and those we are going to convert into percentage. So the numbers I'm going to take is from 1 to 30. So we're going to learn today all the fractions. So let's say if I start with the number 1 over here. So 1 upon 1, if I do in terms of percentage, we have to calculate. So remember that. And if you look over here, this would be nothing but 100%. Now, when you go to 1 upon 2 into 100, I would be writing as what, 50%. So wherever in the problem you need to calculate 50%, just calculate 1 by 2. Keep dividing by 2 so that I can remember the other fractions out here. So there's nothing but 25%. 1 upon 8, if I do, that is nothing but 12.5. I'm just dividing by 2 so that you can remember each of these fractions with ease. 1 upon 16, if I do, that is again 12.5. If I divide by 2, that is 6.25%. Now remember that you have learned so far 1 upon 2, 1 upon 4, 1 upon 8, 1 upon 16, but these are not the only fractions which you have learned. You can actually use these fractions to generate more fractions. Like what I mean is, in a problem, if they ask you to calculate 37.5%, okay? So what I can write this as using these fractions over here, the percentage part, 50 minus 12.5, can you look forward to write? What is 50 if I look 1 upon 2? This is what 1 upon 8. So what do I get is 3 upon 8. So 37.5 percentage if I write in a fraction by removing the percentage sign, I would look forward to calculate 3 upon 8. Similarly, if I look at 62.5%, if I wanted to calculate in the problem, so there's nothing but 50% plus 12.5%. So this time it would be the addition. So 1 by 2 plus 1 by 8, I would be getting what? 5 upon 8. So in a problem, if they ask you 62.5%, just calculate 5 by 8, you would be able to figure out the answer. Let's quickly have one more percentage figure out here, 87.5%. So that could be written as what? 100% minus 12.5%. What is 100%? 1. What is this? 1 upon 8. So if you calculate 7 by 8 of a number, it is actually calculating 87.5%. So these are the fractions what we have learned. Let's move further for the other fractions. So 1 upon 3, if I calculate, that would be nothing but 33.33%. Just further do half of this. So what do I get is 16.66%. So this is used a lot of times, 16.66%. So remember 1 by 6 you need to calculate. If you go further 1 upon 12, that would be what? 8.33%. If you go further dividing by 2, 1 upon 24, that is not important fraction, but we can easily calculate that would be 4.16%. Now, one percentage figure is used heavily, 66.66%. So can you look over here? There's nothing but double of 33.33. So you just need to calculate 2/3 of the number so that you can look forward to calculate 66.66%. Now, if you write the series, it is a very easy one. 1 upon 5, if I calculate in terms of percentage, that is 20%. 1 upon 10, if I calculate, that is what? 10%. 1 upon 20, I'm just dividing by 2, nothing else I'm doing. So that is what? 5%. Let's come to 1 upon 7. That is interesting out here. So it comes out to be 14.28%. So you can see 14 is what? Double of 7. 28 is what? 4 times of 7. Just a way to remember. When you go further, dividing by 2, what do I get? 7.14%. 1 upon 28, not that important fraction, but if you divide by 2, you can easily figure out that is a series 3, 5, 7 out here. Now 1 upon 9 is damn important. You find out at a lot of places. So there's nothing but made up of 11, 11.11%. And when you do it, the same thing with 1 upon 11, there's nothing but made up with 0.9. So 0.09%. So you may find out 1 upon 18 easy with this number 1 upon 9, just dividing by 2. Again, not that important fraction out here. So 5.55 I can write, and 1 upon 22 will also be pretty easy. 4, 5, 4, 5, and so on. Now, I'm just writing some percentage figures which can be easily figured out with these fractions out here. Let's say one fraction, if I want to figure out for 27.27% in a problem. So you can see there's nothing but 3 times of this. So this would be nothing but 3 upon 11 I have to calculate. Let me put 44.44. So you need to figure out these with the help of these fractions. So there's nothing but 4 times of this. So I just need to calculate 4 by 9 of a number to calculate 44.44%. So let's look at some other fractions out here. So let's say if I go to 1 upon 13, that I easily remember with unlucky and lucky. So 13 is generally considered to be unlucky number, 7 lucky. So when you divide with unlucky, you get actually lucky number 7.7% over here. 1 upon 26 is not that important fraction, but if you want to remember, just divide by 2, so 3.85%. 1 upon 15 is also pretty easy to remember. What is 5 plus 1? 6. Just a way to remember 6.66%. And 1 upon 30, you can easily remember just dividing by 2. So that is 3.33%. So these reciprocals are damn important if I look from the perspective of QA questions as well as in the data interpretation also. Now, when you move to another fraction, 1 upon 17, so that also can be remembered with ease. 100 by 17 is if I divide 5 times, okay. Now, decimal point is very easy to remember. 7 plus 1 is 8, so 5.88. Now, if you come to another set of fractions to be remembered in percentage, so we can remember the fraction 1 upon 19, 1 upon 21 with the help of 1 upon 20 actually. So there's nothing but 5%. This is approximately 0.25 more, so 5.25%, and 0.25 less, so this 4.75%. Just a way to remember, nothing else, right? Now, when you come to 1 upon 23, interestingly, you can remember this with 1 upon 29. So what is 1 upon 29? It's a series 3, 4, 5. Pretty easy to remember. Just swap 4 and 3. So you get 1 upon 23. Now 1 upon 25 would be pretty easy. In 200 if I do, that's 4%. 1 upon 27 into 100 is nothing but 3.7. So this was 27, this is 37. So instead of 2, you get 3 over here. Of course, there is a decimal point out here. So we are done with all the fractions from 1 to 30. And these fractions are damn important. Now we're going to use these reciprocals to understand the concept of triplets and the concept of change of base. So of course, the problem which I'm going to ask you as of now, you can easily answer with your approach, but you will find out the reciprocals to be very handy right now. So let's say you have an initial value y and you increase it by, let's say, 20%, and it becomes the final value. Now my question to you is, by what percentage the final value has to be decreased so that it becomes the initial value? So let me make you understand the problem with the solution also. So a lot of people have the tendency to take the initial value always as 100, or maybe if they remember their x a lot, in that case they do take the variable x to figure out the answer. So you can do with both the methods, with 100 also, with x also. So we are going to look at first with the method of 100 out here. and then I'm going to teach my way out also over here, which would be really beneficial, right? So why I'm going to teach this method is because every time the number 100 may not be convenient. Over here in this problem it was, so from 100, if I increase by 20, what do I get is 120. So now you will understand the change of base also concept. So 20 percentage was done on the value 100. Now, if I want my final value 120 to become the initial value that is 100, so I have to have a change of 20 on 120. So this is going to give me what? 16.66%. So you understood the change of base also, because initially I was looking of calculating 20% on the initial value. Now, what we have done is that change of 20, what we got, we are calculating on the final value. So the base has got changed. So you can also do it with X, already I talked about. But let's come to triplets. Over here also, we are using triplets, of course, a set of three numbers. But we are going to use triplets based on the reciprocals, what we have learned over here. So what is 20% if I look in fraction, that is 1 upon 5. Okay. Now look, with ease you're going to get. Over here, we had to actually simplify also this as 1 upon 6. So we don't have to do anything over here. We have to calculate 1 upon 5. What is there in the denominator? 5. So let's take, instead of 100, take 5. 1 upon 5 of 5 is damn easy, 1. What does it become? 6. So on 6, you have to reduce by 1. So what is the percentage decrease we have to do? 16.66%. So what is happening with those reciprocals? We are actually able to figure out the simplified fraction immediately. So that is going to take less time as compared to what you do with 100. Even when you have difficult figures like this, let's say, if the question would have been initial value, whatever you have, there is a 9.09 percentage increase. So what should be the percentage decrease on the final value? So that becomes the initial value. Now taking 100 would have been a bit challenging. So let's use those reciprocals. What is this? 1 upon 11. So let's take initial value 11. 1 upon 11 of 11 is 1. 11 plus 1 is what? 12. So we have to do a change of 1 on 12, and we can easily do it. That would be coming out in terms of percentage 8.33%. So look, whenever the percentage figures are really difficult, every time taking 100 will not be easy. So kindly shift yourself to the method which I'm teaching in this video, and you will really find it very convenient. And a lot of questions, if I look over here, when we talked about in Quant, or maybe we talked about in the data interpretation also. So this was the concept of triplet and the change of base. Let's look at few more examples, and then we are going to understand more about the triplets. So if you look over here, see the same problem I wanted to put in another language also, because at times they can give you this language also. Let's say there is a person A and there is a person B. Income of B is 20% more than income of A. Now the question is, by what percentage is the income of A less than B? So again, if I look over here, the concept would remain the same. Only the language has got changed. So what we are going to do is, this 1 by 5, again we'll pick up 5, income of A, 1 more, so I'll get income of B, that is 6. So by what percentage income of A is less than B? So we are going to compare with B. So change of base is happening. So 6 would be there in the denominator. 1 upon 6, again, if we calculate, that is 16.66%. So I just changed the language. So something like this can also be look forward to ask from your aid. So let's look another problem out here, and please understand this, because this would be the basis to answer a lot of questions in the percentage also, and especially in the topic like profit loss discount also. So what I'm doing out here is, let's say you have initial value I, and I'm increasing it by 20%, and then I'm increasing it by 25%. So no doubt it's a concept of successive percentage change, which we are going to deal separately. Over here, we're going to use the multiplying factor or the triplets to make things easy for you. So let's say if I wanted to find out what is the net change out here. So you can use the multiplying factor in decimal points also, but that may not be convenient. Let's see over here. So there's nothing but 1.2 times of initial. When you have a 25% increase, so 1.25 times of 1.2 initial. So this number, if you want to calculate, it won't be that convenient to you in multiplying the numbers in decimal. So better advisable is that you can use the reciprocal concept out here. Let me teach you again over here and use those figures. So what was 20%? That was 1 by 5. So what is the multiplying factor? 1 plus 1 by 5 if it is increased. If it would have been decreased, then 1 minus 1 by 5. So you have to look at the sign also. So there's nothing but 6 by 5 of the initial time. What is 25%? 1 by 4. So what is the multiplying factor? 1 plus 1 by 4. So what do I get? 6 by 5 into 5 by 4 into the initial value. This is my final value. So this would cancel out. So what is the final value I'm getting over here? 3 by 2 I. So you can look forward to use that concept of f upon I minus 1 into 100 to get the percentage change. So this is what I'm using over here. So I can straight away write the multiplying factor also because I would cancel out. So 3 by 2 minus 1 into 100 would give me 50%. So the decimal conversion, if I do it and then I try to multiply, is generally on a difficult side. So always try to use this approach. Even in problems like these, let's say if you had something like this, 9.09%, okay, 8.33%. So of course, you would not like to convert into decimal and multiply. You're going to use the fraction. So let me tell you. So there's nothing but 1 upon 11. So what is the factor we're going to have? 1 plus 1 by 11. This is what? 1 upon 12. So what is the factor we're going to have? 1 plus 1 upon 12. Let's calculate this ultimately, right? So we just need the multiplying factor to get the percentage change. So there's nothing but 12 upon 11 into 13 upon 12. So what do I have is 13 by 11. So using this, guys, can I look forward to right away 13 by 11 minus 1 into 100? So what do I get over here is 2 by 11 into 100. What is 1 upon 11? We already did 9.09. So 2 upon 11 would be nothing but 18.18%. So look, with ease, with the multiplying factor writing in terms of the fraction, we are actually making it damn easy. Now, one more approach I wanted to tell you over here so that at times that approach also can be used in the problems, especially in the profit loss discount. So I'm using the concept of triplet to wind up the session also, and make sure that you do check out the further videos uploaded in the playlist so that we can look forward to the application of the concept what we have done today in the problems further, right? So what I'm teaching you is like you had 20% and 25%. So 20% was 1 by 5. Okay, so let's take the initial value as 5. One increase, you would have what? 6, right? Now 25% on the value 6, but when you calculate 1 by 4 of 6, that is not coming in integers. So what I'll do is I'll take a separate number. So 25% is 1 by 4. Let me put 4. 1 increase. So what do I get is 5. Correct? Now these two numbers have to be made same so that we can compare and we can use the LCM concept. So what is the LCM of 6 and 4? That is 12. So let me multiply this with 2 out here throughout. This I would be multiplying with 3 throughout. Now I can compare. So this is a triplet what I got. One number is 10 initial. The middle number is 12 and the final number is 15. So using this again, can I say final upon initial minus 1 into 100 would give me what? 50%. So we could have done this again with ease with the triplets also. So remember this method, what I have taught you. Of course, I'll be looking at success percentage concept also later on to find out the net percentage. But for today's class, we are looking at the multiplying factor and the triplets out here. Now, what is 9.09? That was 1 upon 11. So let me pick up 11, 1, 12. Now, 8.33 is actually 1 upon 12. So I don't have to take a number separate than 12 because 1 by 12 of 12 would be very easy to calculate an integer. So what do I get is 13. So what is the final value? 13. What is the initial value? 11. So again, I could have done this using these numbers out here and I would be getting what? 18.18%. So I have taught you both concepts out here, multiplying factor and the triplets also. Successful concept we are going to look at later on. So keep following us on the YouTube channel Cat2IM by Manoj Mahajan and make sure that you share with as many CAT aspirants as possible so that they can benefit. The complete QA full course would be there on the channel. So do subscribe, do join the Cat2IM Telegram information group also so that you can uh, be aware of the latest updates, latest information, free material also. I'll also in the description of the video, uh, I'll paste the link of the Telegram group. Thank you so much.